So we are done with your unit 2 and unit 1 and unit 2, wherein we recall about the coordinate system, the rectangular and the polar coordinate system. So we will now proceed with the first type of curve, which is what we know as the straight line. That is our unit 3. So in this unit, your desired learning outcomes is to know the general and standard forms of line, and of course to understand the relationships of line. Okay, so first is your straight line. So straight line, but before we will go to straight line, let's first define what is curve. Okay, so if we say curve is a path, or we call that one the locus of points, which move according to a given law, commonly known as the function. Okay, so we are considering here lots of points, which are actually, if we are going to relate these points, we call that one the path or the locus of points. And the movement of that locus or the movement of that path is, let's say, that is following a certain equation that is what we call as the law, or that is the function or the equation itself. Okay, and one type of the curve is what we call as the line, which is actually a locus of points which follow a straight path. So that is a straight line, or we call it simply as line. It is a straight locus of points. Okay, so we have here your general form for line. Okay, so ax plus by plus c equals 0, wherein of course x and y are your variables, and then a, b, c there are your constants, or these are the coefficients. We call it this one coefficients. And then of course, if you're going to rearrange this one into such manner that you can find parameters, if you say parameters of lines, these are the values that will describe the orientation and the characteristics of line. Okay, so if you are going to rearrange this general form, we are going to play around with this type of equation, you will end up with such standard forms. We call this one standard forms. Okay, so we have here, actually there are more than 3, but actually I will only introduce you the commonly used, okay, the 3 commonly used standard forms of line. Okay, so first is your slope intercept form, or let's try to abbreviate that by SIF. Okay, so if you say SIF, that means slope intercept form. Okay, why do we call this one as the slope intercept? Okay, why do we call this one slope intercept? Because if you are going to rearrange this equation in such a manner, you will follow this one, wherein y is equal to mx plus b. This number m paired with x, and that b has something to do with the line, or it will describe actually your line, or we call that one parameters of a line. So if you'll try to go here in our description, what is that m? That is the slope. Okay, we discussed what is slope, isn't it? That is the steepness of the inclination, or the inclination. And that number there, which is b, okay, by the way, your variables here are only x and y, since we use that one as in your general form. So the rest there are just constants, or what we call this one coefficients. Okay, so what is m? That is slope. What is b? That is what we call as the y-intercept. So if you will try to go here on this drawing that I prepared for you, you will be having here such a point at the y-axis where the line will intersect that y-axis. And you will have a coordinate, of course, of 0 and a number b. Of course, 0 because your x here at the y-axis is 0. Okay, all the points within your y-axis is aligned with 0, x, so the value of x is 0. But of course, there will be a certain value of number there for the y coordinate. So that is your b. Again, that is the y coordinate, I mean y-intercept, or that is where the line will intersect y-axis. So you can find that one. If you will rearrange this into a form y equals mx plus b. Okay, that's why we call this one slope and intercept, because you can find there m, slope, and b, the intercept, or the y-intercept. And we have here another, which is, so we call this one intercept form, or we will try to abbreviate that one by if. You'll try to rearrange your equation, and you will have there the variable x over a certain number plus a variable y over a certain number equals unity, or we call that one 1, or of course 1, but we sometimes call that one as unity. Okay, so x over a number plus y over a number, if that is equal to 1, the number below this x and y are actually the intercepts. Okay, so the number below the x is a, or we call that one the x-intercept. And of course, just like a while ago, the number below that y, which is, we denote that one as b, that is your y-intercept. Okay, that will only happen again if you will try to rearrange this one into a fraction, and then x and y is the numerator, and then the other side is equal to 1. Okay, intercept form. You can only find there an intercept, the x and y. And this is also another commonly used. So actually, this is the commonly used equation in calculus, your point slope form, if you are getting equations, okay, equations of lines. Since most of the time in calculus, what we can get is the slope. So, and a given point is given, so we will be using your point slope form. Okay, let's abbreviate that one by PSF. But why do we call this one point slope? Because in this standard form, you can find the slope and a point on the line itself. So again, m there is the slope is equal to, isn't it that if you will try to recall your slope, that is delta y delta x, change of y change of x. So let's try to write down that change of y as y minus y1, wherein y is unknown, that is a variable, and y1 is given, that is a coordinate of a given point. And below is your delta x, wherein that is x minus a given value of x. Okay, we will not be substituting, of course, values here of 2y and 2x, because of course you will end up with a value of slope. But what we are after here is equation, isn't it? So you should have there a variable x or y. That's why we only substituted 1 point. So again, point slope form, because you can see there the slope m, and you can see there the coordinate of point 1. Let's say coordinate of point 1. So you will have there x sub 1 and y sub 1. Okay. So that P1 there is a point where line passes. So if you'll try to look at the figure, okay, by the way, again, a while ago, A there is your x-intercept. That is where it will intersect your x-axis. So the coordinate of that point is a number and 0. Why 0? Because your y-coordinate within your x-axis is 0. Okay? All the points within your x-axis, y is 0. So the number only there is the x-coordinate. So that is your actually x-intercept. And then we have there, let's say we will be considering any point here somewhere there in the line. That is the point that actually you can reveal that one if you will try to rearrange in a point slope form. There are a lot of ways for you to simplify it into point slope form. So it depends on what point it will be giving you. Okay, but certainly you will be having 1 point and a slope. Okay, so by the way, what if your line is just vertical, straight vertical, or straight horizontal? Okay, if a line is just straightly vertical, that is just a line passing at a certain value of x. So let's say, for example, okay, we have here a line passing at -2. What is the equation of that? That is just x equals -2. Okay, so the equation of a vertical line is just x equals, where it will be passing your x-axis, or we call this one the x-intercept. Okay, so if you will find that x equals a number, that is actually a line which is vertical. How about horizontal? That is the other way. Y equals a number, or y equals the y-intercept. Let's say a line, a straight line passing, straight horizontal passing at y equals 4. Therefore, the line is y equals 4. Okay. So that is your straight line, general form, and then standard form. So if you are asked certain to, let's say, determine an equation of a line, your final answer should be written in a form of general form, unless stated that it is required to be in standard form in any of these standard. But if there is no given requirement, then automatically you should put that one in its general form. Okay. So let's have an example. Okay, so given the line 2x minus y minus 3 equals 0, express into its standard forms and determine its parameter. So if you say parameter again, those are the slope, intercepts, and a point, if you can find a point. So first, let's try to rearrange this. Isn't it? This is in your general form. Okay, number x, number y, plus number. But of course, the negative there only means that your coefficients a, b, or c is negative value. So let's try to rearrange this one into your SIF, your slope intercept form. This is again the form y is equal to mx plus b. So I will separate y alone, positive, that should be positive. So I will transfer 2x on the other side to be negative 2x and 3 to be negative 3 to be positive. And of course, you are left there with negative, but that is not yet. Why? Because that should be positive. So what will I do? Play around with this. Divide both sides by negative 1 or multiply both sides by negative 1. Make a way to make this y negative y positive. So let's say I will multiply both sides by negative 1. You will have here positive y equals positive 2x, and that will now become negative 3. So this is now in the form of your slope-intercept. Therefore, you can actually get the number paired with x as is. If that is negative, get the negative. However, that is just positive, so your slope means positive 2. And you have here plus b, that should be plus b. So if that is minus, therefore if I will make that plus, your b is negative 3. So your y-intercept there is negative 3. Okay, what else do we need? We need to find your x-intercept A, or the point that is given, or where the line is passing. Okay, so let's try to transform that one into intercept form, this form. Okay, so how will I do that? Of course, I will put x and y on this side. Okay, so this 2x minus y will remain. This 3 will go positive on the other side. And then all I need to do is make your constant on the right side equals to 1. So divide both sides so that that will become 1. Divide both sides by 3. So everything will be divided by 3. You will have this 2x will be divided by 3. However, that should be x only on the numerator. So what will I do? I will return back your 2 below, so that will be 3 halves. Isn't it? That is your rule in your fractions. If you will try to transfer that on top, if you are dividing a certain number by a fraction, that will flip. So it will go back to 2x over 3. So again, your number below x, that is your a, or your x-intercept. So that is positive. So positive 3 halves, or 1.5. So it means it will pass x-axis at 1.5 and it will pass y-axis at negative 3. So later on we will see. This is drawn for you. Okay. So if you will try to look at this, that should be plus y over b. So that is minus. I will make it plus by putting the negative below together with 3. So your y all over negative 3, so b there is negative 3, which is what we get a while ago, isn't it, from your slope-intercept form. Okay. So now, of course, that is 1. So putting it into your intercept form, you can get your a and b, your y and x-intercept. Now, let's proceed to your point-slope form. Okay, this is the form again. So what will I do? I need to put y on top, below is x. So what will I do? Let's say I will put here x and then transfer y. You can put 3 together with y, or you can put it together with x. It doesn't matter actually. What you will be getting, of course, are different points, but the points are still on the line itself. Okay. So let's try to put your y on the other side, so that will become positive y, and then of course I need to put x below. However, that should be y only and x only, paired with a number, but that should not be multiplied with a certain number. So what will I do? Okay, for me to factor out there 2, so that will just become x, I need to make your constant together with x a number that is divisible by 2. So it's either you will subtract 1, so that will be negative 4, so that it will be divisible by 2, or what will I do? I can actually add positive 1. But what will I do? I will do that one on the other side, or simply, if you will take away something from 3, you need to transfer that on the other side. Or if you added something here on this left side, you need to do that one on the other side. That is the rule of algebra, isn't it? We keep on reiterating that one in your algebra. Okay, so let's say I will take away here a negative 1, put that one on the other side, that will be a positive 1. Why? So that will become 2, and that will be divisible, both by 2. So now I can factor outside your 2, you will have here x minus 1 left. By the way, why are we doing this one? Because again, if you'll try to look at your point slope form, that should be y only and that should be x only. It so happened that on this side, that is only y, so no problem with that. Okay, so now what will I do? I do not need that 2. What I need is x minus 1 below, so divide both sides by x minus 1. So that will go below y plus 1. And of course, the 2 there will remain, and that is actually your m. The number that will remain on that side is actually your slope. So the same, isn't it? That is what we get from your slope-intercept form. However, okay, if you try to look here in your point-slope form, y minus y1, x minus x1, that should be that should be minus always. So what will I do? That is plus the y plus 1. So I need to make that minus. So your negative will go on 1. So that will be negative 1. Minus negative 1, or if you will put that back, that will be plus 1. Okay, therefore y minus y1. So your y1 is actually a negative 1. And then x minus 1. So your x1 is actually positive 1. So your point where the line passes is at 1, negative 1. Okay. That is getting parameters and then of course rearranging your general form into standard forms. Okay, this is important also. This next slide is important, a very very important topic on lines. It is not just enough for you to manipulate standard form and general form. You need to know also how to relate lines with another lines, okay, or with other curves. Okay, so we have here what we call as the relationship of lines. So, kung kayo may relationship kayo, yung lines meron din. Okay, so we have here the first one, your parallel lines. If we say parallel lines, these are lines with equal slopes. Okay, so kailan magkakaroon ng equal slopes? When do we have an equal slopes? Of course, if your angle from the horizontal is the same, isn't it? Because what is slope again? If you will go back in our Okay, let's go back to our discussion on slope. So need that, where's that? Slope, slope, slope. Slope, yun, okay. So slope is either tangent theta or that is rise over run or delta y delta x. Okay? So however, we cannot figure out right away your y delta x, but we can actually figure out your theta. The theta is the angle from horizontal. Okay? So slope could be tangent theta also. So if you'll try to go here, how can you say that these slopes are parallel or they do not meet? Okay? They have the same angle from the horizontal. We can call that one as parallel, and we are sure that that is parallel. By the way, what is parallel? They will never intersect. That is the meaning of parallel. Okay? They go on the same direction, but they do not intersect. They do not align with each other, so they go separate ways, but of the same direction. Parang kayo din lang, pinagtagpo pero hindi kayo pinagtadhana. Kahit i-extend mo yan kahit saan-saan, hindi talaga yan magmimit kasi nga parallel yan. Okay, so how can we define now? How can we relate these parallel lines? Is again, I will repeat, the slope of a line, if that is parallel to another, their slope will always be the same. So let's say this line on top is L1, that line below is L2. So the slope of L1, let's say that is m sub 1, and the slope of your L2 is m sub 2. So they will always be equal as long as they are parallel. Okay? So by the way, how can you see that one even without drawing and solving your slope or without even knowing the angle from the horizontal? You can actually decide that that is parallel by merely looking at the general form. Why? Because if you try to look at the general form, of course, this is the general form, ax plus by plus c. The only difference of a parallel line is the constants. Okay? The coefficient of x and coefficient of y are always the same if they are parallel. The only difference is the constant. Okay? So by merely looking at the general equation, you can actually say that they are parallel. So how can you prove that one? Okay, you might be asking, how can you know that one? Okay, let's try to prove that one by your SIF, that is your slope-intercept. If you'll try to rearrange your line 1 and line 2 into its slope-intercept, you will have this equation of line 1 to be y equals, okay, ax and c1 will go negative on the other side and divide both sides by b. So your slope here will be a over b x. Don't worry about the y-intercept, okay, that doesn't matter. Okay, by the way, that should be c sub 2. Okay, wait, let's just leave it as is since cannot edit it on the PDF. So that should be c sub 2. Okay, but actually that doesn't matter because what we need to focus here is the slope. Okay, so again, if you will rearrange your L2, that will be the same. The only difference actually is your constant. Again, that it should be c sub 2. Okay, that is just a typo error. So the same, you will still end up here with a divided by b, which is negative, and a divided by b. So the point here is that the slopes are still the same. So that is what we want to prove. So that we can say that in this form of your general form, you can say that these are parallel. Okay, so that's it for parallel lines. And we have the next one, which is what we call as the perpendicular lines. Okay, by the way, this is important here also in your parallel lines. In intersecting lines, the opposite angles are the same, isn't it? If we say intersecting, they will meet at a certain point. The opposite angles are equal. So the angle here, let's say here on top, is the same as the angle here below. If you are considering two lines that are intersecting, so that is a common knowledge on angles. But the new here in parallel lines is that what if these two parallel lines are intersected by a single line, a different line, okay, which is not parallel with them. If they will intersect both of the parallel lines, then the angle here, look at this. This small angle here is the same as the small angle there, which is alternate. The alternate angles are the same. So what does that mean? If this small angle and that small angle are the same, since that is a straight line and this is the straight line, the remaining angle here, the big remaining angle here, which is, let's call that as beta, that's alpha, that is read as alpha, guys, and this is beta, that is theta, of course. So again, if these alpha are the same, the remaining angle, which we can call beta, are also the same, since we are referring to a straight line in the same straight line. So if that is angle is the same as that, the remaining will also be the same. So that is additional information for angles in your parallel lines, which is intersected by a different line. Okay. So these are the parallel lines, line 1, line 2, but that is another line which intersected both of them. So again, this is important. Okay, this is useful, very, very useful in your higher subject. Okay, so perpendicular lines. Okay, so if you say, okay, if parallel lines are not meant to be, perpendicular lines are also not meant to be, but at least they will meet at once in a lifetime. They will meet here at a single point, and actually you can say they will meet at any point, but the what do you call this one? The uniqueness of your perpendicular line is they will meet at a right angle. That's when we can call it as perpendicular. If they will just meet at a certain point, that is intersecting lines. Okay, and that is common. But when they will never meet, that is parallel. But if they will meet at a right angle or at a 90 degrees, that is a perpendicular lines. Okay, that is a very, very important relationship of lines also. So they will meet at a right angle. So what does that mean? Okay, they will meet at a right time, but they will go on separate ways. But at least they will meet at a right time or at once at a right angle. Okay, so let's say this is your line 1. So M1, of course, the slope of that is M1, and then that is line 2. The slope of that is M2. What is the relationship of that? So if parallel is they are equal, how about perpendicular? Okay, that is slope of the other line is negative reciprocal. Okay, we call this one reciprocal or the inverse. Okay, the slope of the other is a negative reciprocal of the perpendicular line with that. Okay, so if you want, let's say you have there M2, substitute M2, you will get the M1. Or let's say what you need is M2, all you need to do after this interchange this one, isn't it? Cross multiply, this M1 will go down and M2 will interchange to be there. So you can interchange M1 or M2, it doesn't matter as long as they are perpendicular. That is the relationship. Negative, okay, this is the common mistake. The others are actually forgetting about the negative. Okay, so how about in your by the way, in your parallel, you can actually look at that relationship by merely looking at the general form. The same with your perpendicular, but in parallel, the A and B should be the same, but in your perpendicular, they will interchange, okay? The A, which is for X, and B for Y, will interchange. So B will go with X, and then A will go with Y, and one of the sign will change. It's either B will change or A will change, okay? So again, the coefficients of X and Y will are interchanged, and one of these will change sign. It's either A or it's either B. Again, don't worry about the constant. That is just the constant. What we will be focusing here is the coefficients of X and Y. Because if we will try to prove that one again by SIF, you will end up here with the slope of line 1 to be negative AB, just like a while ago. But for a slope now of your line 2, again, that should be C sub 2, guys. Okay, that should be C sub 2. Okay, the slope of your line 2 will now be positive B over A. So it is a flip value of AB, isn't it? A over B, that will be flipped into B over A, and that will be changing sign because of the negative. Okay, so perpendicular and parallel lines. Let's have an example for this relationship of lines. So find the line. Okay, find the line. First is a parallel, and then second is the perpendicular to this given line 4x minus y equals 5, which is passing at 0.35. So we are trying to find a parallel line with this given and a perpendicular line to that given, which are passing at 0.35. Okay, so what are we going to do? Make use of your standard forms. We are trying to find equation of line. Okay, if we say find the line, it means find the equation of line. So we are finding an equation of line. So where are we going to start? Actually, we will try to make use of the standard forms. If we know the parameters, input that one in your standard form, play around, and then have the general form. And at the same time, of course, you're given there the relationship parallel perpendicular. Okay, so let's start with your given line. So let's say 4x minus y. Okay, I will transfer that one to be the so that will become the general form. So that given line, let's try to denote that one as L sub O, or the line original, or line O. Okay, so it's up to you how you will name your lines. And then of course, for me to have the slope of the parallel and perpendicular, I need to know the slope of that given line, isn't it? So what will I do? I will rearrange this one. It's up to you how you will find your slope. You can make use of the point slope form or the slope intercept, but it is simpler to transfer this one on the y is equal to mx plus b, which is your SIF, slope intercept. So if I will try to transfer y there, it will become positive y. So that is y. Y will go positive on the other side. 4x minus 5 will remain. So actually that is already in your slope intercept form. So the number paired with x is your slope. So that is the slope of your line sub O. Okay, that is your m sub O. So now, what are we going to solve? Let's try to solve first your A, your parallel line to that L sub O. Okay. So actually, if I will draw that one, this is your L sub O, your black line. So what I will be finding first is your parallel line. That is the unknown at A. So let's say I will put that one as L sub A. Okay, but that is your parallel line. And that parallel line is parallel with your line sub O or L sub O. At the same time, it should pass 0.35. So what do we have? Okay, so question, we are trying to find equation, and what is given is a point. So you cannot make use of your SIF, you cannot make use of your IF. What we will be using is your PSF. Okay, your point slope form. So that is what we will be using, your PSF, point slope form. Okay, so we need to, if we say point slope form, you need to have the point. Of course, you already have that. You need to have the slope. That is what we need to have. But that is when we will be using the relationship of parallel. L sub O is parallel with L sub A that we are trying to find. So their slope should be the same. So the slope of that parallel line is the same as the slope of your L sub O. So if that is 4, M sub A is also 4. Now you have the slope, you have the point. Make use of your point slope form. This is your point slope form, isn't it? So what is our slope? That is 4. Y minus, what is y? 5. X minus, what is x? 3. Okay. Play around with that. Cross multiply. Cross multiply. This on the other side, it will multiply with 4. And y minus 5 will remain there. 4 times x is 4x. 4 times 3 is negative 12. And that will be y minus 5. Rearrange. So again, as I'm saying before, always put that one on the general form. Your final answer. So 4x will remain there, y will go minus, okay, negative will go plus, so negative 12 plus 5 will be negative 7. So that is your L sub A, or that is our parallel line to the L sub O. So this is your red here, which is the parallel line. And then second, your letter B is your perpendicular line. So again, the same. We will start with your point slope form because that perpendicular should be still pass at 0.35. Okay. So this is your 0.35. That is the given line. So the parallel and the perpendicular should pass at that 0.35. Okay, so we need to find the slope of that perpendicular line. So what again is the relationship of perpendicular? The given slope is negative reciprocal. Okay. What do we have? Slope of MO or line O. So that they are perpendicular with the unknown L sub B. That is your perpendicular line. Let's denote that one as L sub B since that is under letter B. Okay, so the slope of your perpendicular line or M sub B is negative of 1 over MO. What is MO? That is 4. So your M sub B or slope of perpendicular is negative 1/4. So again, substitute in your point slope form. M is equal to Y minus Y1, X minus X1. Okay, play around. This time, okay, look at this fraction. So get rid of all the fractions. So multiply x3, it will go multiply with 1 there. 4 will go multiply with y minus 5 there. But there is a negative, so it's up to you where you are going to carry the negative. If you use that one in your negative 1, the 4 should be positive. But if you put that one below as negative 4, the 1 should be positive. You should only make it once, use it once. But for me, I want to make this left side positive already, so I will put that negative together with your 4. So it will go negative 4 multiplied on your y minus 5. X will be multiplied with 1, so that will never change or that will not change. So again, your negative, again the negative goes with 4, it will be multiplied, cross multiply here. So negative 4 times y minus 5 will be negative 4y plus, it will become plus 20. Rearrange x. Negative 4y will go positive, 20 will go negative, and it will add with negative 3, so negative 23. So that is the slope of our perpendicular line. Okay, so this is the drawing of that. Try to check that one, isn't it? By merely looking at the general form, you can say that they are parallel or perpendicular, isn't it? As I've said that one a while ago. This is your line, and that should be parallel by this. So if you'll try to look at the coefficients of x and y, that should be the same. 4 and 4, yes. Negative 1 and negative 1, yes. It doesn't matter about the constant. Okay, so yes, you can say that they are actually parallel. LO and L sub B are perpendicular. So what does that mean? The coefficients of A and B of x and y should interchange and one of the sign will change, isn't it? So that is 4 and that is 1. They will interchange, that should be 1 and 4, and then the sign will change, wherein actually the sign of negative 1 will become positive. So yes, that is perpendicular. Okay, so that is relationship of lines. Okay, I will be having that activity. Solve that one and submit. So we will proceed with your unit 4. Okay, that is for a while ago is your straight line. We will now proceed with your circle. Okay, circle. So in this unit, that is your unit 4, we will be of course having this learning outcome for you to know the general and standard forms of circle also, and then of course to determine tangent lines to a circle, to a given circle. Okay, so there is now a relationship. We will try to relate lines and circles. But first, let's try to understand the general and standard forms of a circle. Okay, so what is a circle? Okay, so a circle is a locus of point. Okay, these are still a curve. This is of course a curve. By the way, if we say curve, technically that could be any equation. Okay, any equation or locus of point. However, we are used only of knowing curve to be as in curved surface. But actually, a line could be considered as curve, but only that is following a straight locus or a straight path. But that is still a curve. But okay, a circle there is a type of a curve wherein the locus of those points moves at a constant distance. Okay, the locus or that is the movement of the points moves at a constant distance from a fixed point. So what is that fixed point? We call that one the center. Actually, that is what we call as the center of the circle. And then the locus of points or the path is moving at a constant distance or at a fixed distance, which is what we call of course as the radius. So if you will try to measure from the center to any point in that circle, that is the same as the radius itself. Okay, so again, a circle is a locus of point that moves at a constant distance from a fixed point, which is we call as the center. Okay, so by the way, how do you know that that is aligned? Okay, how do you know that that is aligned? That is linear equation. Okay, if you say linear equation again, x and y is only first degree. It's either x only is there, if that is a vertical, or it's either y only is there, if that is a horizontal. But again, the degree in all of the terms should be, the highest degree there should only be 1. So that should be a straight line or a line. But if that will now be a second degree, any of the x or y is a second degree, then that will now be a curved surface. It is now not a straight line. Okay, so this is a general form for a second degree curve. Okay, this is now for a second degree curve. You will be having there, it's either you will be having there x squared or y squared, or you will be having there both. As long as there is a exponent or a degree higher than 1, that is already a curve. Okay, so that is the general for any curve. Later on, we will be having types of curve. But first, let's focus on circle. So again, let's say A, B, C, D, E are the coefficients. A is for x squared, B is for y squared, C, D, and so on and so forth. But actually, it doesn't matter. It doesn't mean that you need to have all of this. As long as you have x squared or y squared, that is already a curve. Or you will have both. But for a certain curve, which is what we call or what we are discussing now as the circle, the coefficients of the x and y should always be the same. Okay, that is the uniqueness of a circle. Uniqueness of the equation, the coefficients of x squared and y squared should always be the same for you to say that that is a circle. Because if not, then that could be a distorted, that could be an oblong, or we call that one, that will be our next topic later on, as we call that one as the ellipse. Okay, it is an oblong shape, or it will not be forming a closed figure. That could be a parabola or your hyperbola. That will be our next topics. Conics. Okay, so again, if that will now be equal, the coefficients of x squared and y squared, then you can now reduce that into the general form of a circle, wherein that is ax squared plus ay squared. So the coefficients of x and y are the same now. So this is your general form for a circle. And most of the time, actually, you can reduce the general form of a circle by dividing everything in by the coefficient a, so that you will only have the x squared, y squared. Actually, that is what we will be doing if you will try to transform that one into the standard form. Okay, why do we say standard again? Because in that form of the equation, you can get there the parameter or the characteristic of your curve. So what are the characteristics that we need in a circle is you need to know the center and you need to know the radius. That's all for a circle. Okay, so if we will rearrange this one into a form, x minus number, the quantity is squared, or it is a perfect square, and then y minus a number, quantity square, another perfect square, is equal to a number, which is actually you will get the square root. If that is a single number, get the square root of that. The square root of this is your radius, that is your r. And then the number paired with x, if that should be minus, okay, this is also important, that should always be minus. So a number paired with x in your perfect square is the coordinate of the center in the x-axis. And the number paired with y, if that should always be minus, is the y coordinate of the center also. Okay, so rearranging your general form into that standard form, you can get the center of the circle, the coordinates of the center, and you will get the radius of the circle. Okay, so okay, I put here also another note. What if your center is exactly located at the origin at point 0, 0. So if that is 0, if that h is 0, if that k is 0, actually you will now simplify, or you will now make your equation shorter. X squared plus y squared equals a certain number. So that is the equation of general form of equation of a circle having a center at the origin. So wala na ito. There is no cx and dy. Only x squared, y squared. Okay, only x squared, y squared. That means it is still a circle, but automatically the center is at the origin. Okay, So this is a little bit challenging, the transformation of general form into a standard form. So let's have an example for that. So find the parameters and draw the circle. Okay, this is given: x squared plus y squared minus 4x minus 6y equals 12. So what are we going to do? How are we going to get the perfect square here? That is applying your algebra, the completing the square, isn't it? Where's that? No. Here. Okay. So transform that one into its standard form using the completing the square. So paano natin gagawin ulit? Okay. So you need to separate your x variable with y variable, and the constant transfer it first on the other side. But since that is already there, then there's no problem. But if you have that general form, the numbers is on this side, so you need to transfer that. Okay. So you should only left your x and y variables. And at the same time, now group this one, x with x, y with y. So put that x squared and negative for x. Enclose that one. Plus, enclose your y squared with your y. So for us to create a perfect square, isn't it, going back to your completing the square, you need to have this perfect square. Wherein again, how to get this third term or the constant of a perfect square is divide your middle by 2, and then the answer get this, divide it by the coefficient of x squared. But most of the time, of course, that's why as I've said a while ago, if there is a number paired with or a coefficient of x and y squared, it is better for you to simplify it first by dividing all by a, by that coefficient, so that you will only have their x squared y squared, so that it will be simpler for us to figure out the perfect square of the standard form. Okay, but since that is already x squared y squared, then there's no problem. But again, if there's a number, it is always better to simplify it by dividing by that coefficients. Okay, so again, divide your middle term by 2, isn't it? If you want to recall that one, go back to our discussion. We had that one. Divide this one by 2, so negative 4 divided by 2 is negative 2. Divide it by coefficient of x squared, which is 1. So of course, there's no effect of that. So negative 4 divided by 2 is negative 2 square. Get the square of negative 2 is positive 4. So I will add there positive 4. So what I added here, I need to add that also there. So that should be plus 4 also. What you did on this side should be the same on the other side. Now, figure out the third term of your y. Okay, so divide negative 6 by 2, which is negative 3. Divide it by coefficient of y squared, which is 1. It doesn't change. Negative 3, get the square of that will be positive 9. So what you added here, you need to add it also here. Okay, what you put there, you need to put that also there. So now, you can simplify this into its perfect square, perfect square. So this will be x minus 2 squared. If you are not sure, bring it back, that should be the same. And this is also y minus 3 quantity square. Put it back, that should be the same. Simplifying this one, 12 plus 4 is 16, plus 9 is 25. But that number 25, if you will put that one into a number raised to 2, then that number, the base of your square is the radius. So that is 12 plus 4, 16, plus 9 is 25. I will put that one as, I can rewrite that one as 5 raised to 2, or that is still 25. So that means that your center is located at, okay, this is important guys, that should be minus x minus h always, and then that should be minus also y minus k. It so happened that that is already minus, so all you need to do is get the numbers 2 and 3, and that is the coordinate of your center. But if one of that is plus or both of that is plus, you need to make that minus, so the numbers will be a negative. But that is again positive, why that is already minus. So your center is located at 2, 3. Okay, 2, 3. And your radius is 5 units. Since there is no given units, that is not centimeter or meter. Okay, so let's just say units. Okay, so if I will draw that one, okay, by the way, I used here the grapher again, okay, the grapher. But of course, for you, if you do not have a grapher, you can always draw your x and y coordinate. First is to plot your center to be at 2, 3, and then all you need to do is measure 5 units, and then draw that one rotating, so that that will create the circle. Or actually, you can just if that is if you'll try to look at this, From this point going to its top, that is a vertical movement, so that is y. That is your radius, isn't it? So 2, 3. But add 5 since we are going up to your y coordinate. That will be the coordinate of the highest there is 2, 8. Going down, we will subtract that radius from your 3. So 3 minus 5 is negative 2. So you will have there 2, negative 2. They have x-axis as 2. They are all the same because they belong on a straight vertical line. How about here? So that is simpler for us to draw to connect these 4 points. That is the circle. They are on the same level, so their y-axis should be the same. So as you can see, 3, 3, 3. So what will happen with 5? We will add and subtract that one in your x coordinate. So 2 minus 5 is negative 3. So that is negative 3, 3. 2 plus 5 is 7. So that is 7, 3. Okay, so that is connect these 4 points and that is your circle. That's it. So let's go to the tangent line to a circle. This is important because if you are civil engineering, you will go to your of course, all of you will be undertaking your calculus, but for civil engineering, you will be having your designs of highway curves. You will be needing this topic. So you need to know what is the tangent line to a curve. Okay, so a tangent line passes at a single point on the circle and perpendicular to the radius drawn to that point. So if you'll try to look at my drawing here, let's say this is the circle. Okay, I will consider there a single point and a line that passes there that at the same time perpendicular to the radius. If I will draw a radius to that point going to center, that line making a 90 degrees with that passing at single point is what we call as the tangent line, and that point where it passes the circle is what we call as the point of tangency. Okay, so again, as I recall, perpendicular lines have a relationship of negative reciprocal of slope. So again, later on, if we will try to figure out the equation of your tangent line, you will be needing the point of tangency. If that is given, of course, all you need to do is substitute in your point slope form. But if that is unknown, you need first to solve that. But at the same time, we need to know the slope of your tangent line. But of course, we cannot solve that one since in the first place that is the unknown. But we know that they are perpendicular with your radius drawn to that point. So what will I do? Isn't it? If you have there a radius, this radius is actually a line segment connecting 2 points. So if you'll try to recall our coordinate system rectangular, you're given 2 points. You can actually get the slope of that, isn't it? So you can get the slope of the radius, and that is negative reciprocal for the slope of the tangent since they are perpendicular. Okay? So again, this point here where they intersect is the point of tangency. So again, solving for the equation of your tangent line using your point slope form. If you have already your slope of the tangent line coming from the slope of your radius, you will substitute that one. And if you are given your point of tangency, then substitute your y and x coordinate. But if you do not have that one, you need to solve first. So, for us not to be having a lot of examples, I will not be giving example wherein this is already given because that is simple. All you need to do is figure out if this point is given, all you need to do is figure out the slope of r, get the slope of mt, substitute the points and substitute the slope, you will have the equation already. So I'd rather give you a little bit complicated example, okay? A little bit complicated wherein, let's say this is still unknown, the point of tangency is unknown. So I will be giving you that example, okay? So find the tangent lines to x squared plus y squared equals 17. That is a circle, isn't it? How do you know? The coefficients of x squared and y squared are the same. Even if there is no x and y only there, what does that mean again? If you will go back there in my discussion a while ago, that is equation of a circle with the origin as the center. Okay, so automatically this example has the origin at the center. So forget first about this drawing. Let's try to understand first the problem. So we are trying to find a tangent line to that circle, and at the same time that line is parallel to this given line. This is a line, isn't it? Since there is no square. So again, I will repeat. You have a circle, you want to get a tangent to that circle, and that tangent should be at the same time parallel to this given line. So I will draw. That is the drawing of that circle, that is this red. And the line, our reference line for us to say that that is parallel is this one. Actually, that is your red line here also. That is the given. The color red are the given equations. So let's try to put a name since we will be having a lot of lines later on. So if you will have there, let's say that is the reference line, let's put that one as L sub 1, okay? So that, let's say that is L sub 1. So we will be needing later on the slope of that, since again, that is parallel to the unknown line. So we need to find the slope of that. So again, just like a while ago, rearrange this one to point to slope form. I mean slope intercept. Transfer y there, it will become positive, this will go negative 5, but what we need is the pair of x, so that will be positive 4, slope of your line 1. So again, find the tangent line using your point slope form. You need to know the slope of the tangent and you need to know the point of tangency. But in the first place, we do not know that one. But what we can get from your given line, reference line, is that since they are parallel, you can say that the slope of the tangent is the same to that line 1, since again they are parallel. Okay? So what does that mean? So if this is your reference line, we are trying to find a line that is passing at one point in the circle at the same time parallel with this. So there are two chances. It could be at this point parallel to that line, and at this point parallel to that line. So actually you can see there, you can expect two answers. You can already expect there two answers, two tangent lines. So first, again, you need to find this point of tangency. We do not yet know that one. And you need to find the slopes of this tangent line. So by the way, since they are parallel, the slope of this is the same as the slope of that and the same as the slope of the other tangent. Okay? So you already have the slopes. We need to find the point of tangency. So that is the challenge here. How do you find the point of tangency? That's why I gave you this as the example, because once you will now understand this one, the rest will be the same or simpler than this. Okay? So find first the point of tangency. So how will we find that one? Okay? The point of tangency is actually the intersection of the circle and the equation of the radius passing at PT. So that's why you have here a broken line. Okay? If you will try to draw a line which is passing at a radius, or a line which is representing a radius, if we say radius, that will be passing at the center. Okay? If you will try to draw a line there, and since we are talking here of a radius, and the radius should always be perpendicular to the tangent line, isn't it? So if I will draw that one, and that will be perpendicular to the tangent lines, and at the same time, if that is perpendicular to the tangent line, that is also perpendicular to your given line, since these are parallel. Three lines are parallel. So how will I do that? So let's say once if I already know that the equation of my line here, okay, and then I will get the intersection to the circle. That point of intersection of this line and the circle are actually the point of tangency. That is the meaning of the phrase that I wrote here. Okay, if you will try to get the radius equation of the radius, that is actually perpendicular to the unknown tangent line, and then make use of that as equation 1, and then the equation 2 will be the equation of the curve. Solving using algebra isn't it, two equations, two unknowns, since what we are getting is x and y. Two values, x and y. However, since x is squared and y is squared, there are two values of x, two values of y, and that means there are 2 points. Okay, so first I need to find the equation of that radius, and then making use of these equations, applying algebra, find the intersection or the values of the x and y. Okay, so first I need to know, before I will get that equation of this radius, I need to know a point where it will pass, and actually that is the center. That is important. So what will I do? I will put that circle into its standard form to get the center, but actually since that is x squared y squared, there is no partner of that. So x minus 0, y minus 0, and of course the number on this side is already your square root of radius. So get the square root of that, that is your radius, which is square root of 17. Okay, I will use of this as the whole number. But actually I will not be needing this one. Okay, but what we need here is the center, which is actually at 0, 0. So if you have that point where the equation of the radius passes, all I need to know is the slope of that radius. So where do we find that slope of that radius? Let's put that one as m sub r. Again, here. You cannot make use of the slope of tangent because in the first place, tangent is the unknown. But since it says there that the tangent lines are parallel to this given line, that means that is also if that radius is perpendicular to the tangent, that is also perpendicular to the given line. And you know the slope of the given line, isn't it? Which is 4. So we can actually get the slope of this radius, which is using your perpendicular relationship 1 over what is the slope of your line 1, that is 4. So that will be 1/4, negative 1/4, slope of our radius. Okay, so that is the slope of our radius, and the radius is passing at 0.00. So point slope form again, that will be your slope equals y minus y1, which is 0, x minus x1, which is also 0. So actually play around with this, you will have the equation to be x equals negative 4y. So that is actually the equation of your radius, this green. But actually we do not need that one, so I just put it as broken line. Okay, we only need that one to solve for the intersection point. So that is the equation of your radius. So again, as I've said a while ago, you have equation 1, and we will use the equation 2 to be the circle. Why? Because we are getting the point where they meet, the common point within the line in the circle. So all I need to do is solve using algebra. Let's say your equation 1 is the circle, and then equation 2 is the radius line, the line passing at the radius. Okay, so now substitute your LR, that is the equation of the line, to the equation of the circle. Then this x will just become, isn't it, x is negative 4y, so your x in the equation will just become negative 4y. So instead of x squared, that will be negative 4y, the quantity squared, plus y squared, of course, equals 17. Play around with this. Negative 4 squared is 16 plus 1, since that will be y squared, both of them will combine. So 16 plus 1 is 17. Divide both sides, so 17 cancels. Y squared equals 1. So getting the square root of both sides. And this is again important, as I've said before, for a square root, that should be a plus and minus. Therefore, there are two values of y. So if there are two values of y, there are two values of x. Also, therefore, there are 2 points of tangency. Okay, so let's start with your positive 1. So if y is positive 1, where will I solve x? You can use the circle, or you can better use the equation of LR, since that is simplified. So negative 4 times y, your y is 1, so x is negative 4. So you have the first point of tangency at negative 4, 1, which is actually this one here. Okay, the point there. And then substitute your negative y, negative 1 as value of y, and that will become positive 4. So you will have another point, another point of tangency at 4, negative 1. So this is your 4, negative 1. Okay, so you have now the points of tangency. You have now the points of tangency. Actually, we already solved the slope of the tangent a while ago, isn't it? Since it says there that that line is parallel to your tangent lines. So they are equal, which is slope of 4. So making use of that slope of 4 and these points of tangency, let's start with your line 1. Okay, so let's start with your line 1. I will use first the slope and the first point. So ito muna. So your slope is 4, y minus positive 1 equals x minus negative 4, or that will become x plus 4. Rearrange this one, you will end up with this equation. Okay, and then use the other point. Slope is still 4, that is negative 1, so that will become plus. That is positive, so that will still be negative. Rearranging that one, this will be the equation. It looks the same, but they are different in the constant. That is plus 17, that is negative 17. So they are different lines. And as you can see, these are the same coefficients of x and y. So automatically they are parallel since they are both tangent and at the same time parallel to this equation. So if you'll try to look at this equation also, coefficients of x and y are the same with the tangent lines. So that's it. If you'll try to draw this one, so this is now the circle, okay? That is the radius, and that is the center, I mean. The radius of that is square root of 17, but we do not need actually. And this is the line given, the reference line. And are the points of tangency that we solve first. Negative for 1 and then for negative 1. And these are your equations of tangent lines. Okay. So maybe this is the most complicated example that I can give you. So if you understand this one, if not yet, then you can rewind and rewatch the video. So if you understand this one, then there's no problem with the rest because these are simpler and actually these are almost the same as this. So if you have a question, comment below the video. So you have activities, of course. So you have two activities in this video, 1F, assignment 1F and assignment 2F. So please accomplish that one. And if you have question, again, please prepare that one for our live meeting, next meeting. Okay, so that you will be having your live discussion next meeting. Or if you need that one in your assignment to solve the assignment, if you have something not clear for you to solve the assignment, you can always make use of the comment box. Okay, so thank you very much for watching.